Okay, so what we're working on today is we're doing the second part of Chapter 3 notes when we're looking at standard deviation in the normal model. The first thing we have to know is what the standard normal model is. And the standard normal model is when you're going to have a mean of 0 and a standard deviation of 1. The notation that we'll use whenever we have a normal model is we'll use n, and then the mean goes first, and then the standard deviation. Okay, so what happens is, let's draw a normal model. A normal model is a kind of a bell curve. And your curves don't have to be perfect. What matters the most is your tick marks. I always make my mean a little thicker so I know it's the center, and so my mean is 0. For a normal model, you'll have 3 tick marks to the 1, so this is a +1. This is a +2. This is a +3. And there's always a little bit of data outside of it. My graph's not the best, or my picture's not the best. And so when you have a standard normal model, or you have a normal model, everything usually fits, or a large percent of it fits within 3 standard deviations. Okay? This middle standard deviation right here, which is from, let's do a different color. This is where the biggest percent of the data is. 68% of your data lies within 1 standard deviation to the left and right of the mean. The next one, 2 standard deviations away, %95 of your data lies within 2 standard deviations. And then the last one, I should probably choose a different color. It's pretty close to the red. Let's use blue. 99.7% of your data lies there. Okay, and so this is called the 68, 95, 99.7% rule. And so 68% of your data is within 1 standard deviation, 95 is within 2, 99.7 is within 3. That means there is something on the outside. You will see some textbooks that call this the empirical rule. But we're going to focus it on 68, 95, 99.7. There is something that you need to be very careful of. Whenever something says clearly label, you need to make sure that you include those percents. So when you clearly label, you have to include these percents on the picture like we did here to the left. So when we have something that fits a normal model, we want to be able to apply it to the population. And so even though it's just one data set, you should be able to apply it to the population if it's roughly, if it's unimodal and roughly symmetric. So what we're going to do now is we're going to look down here and find some percents. And this is a more applicable problem. Okay, so it says in 2018, SAT scores for high school graduates are unimodal and roughly symmetric. So that means it's going to follow these percents. Okay, the 68, 95, and 99.7. So we have a mean of 1,068 and the standard deviation of 204. It says draw and clearly label, so that means I'm going to have to include my percents. Okay, so I'm going to draw my curve. And you'll get better at these with time. And my mean is 1068. Now I have 3 standard deviations to the above and 3 standard deviations below. And so what I have to do is I have to add 1068 plus 204. So this one is 1272. And then I add 204 again, 1476. And I add 204 again, 1680. And then I find my standard deviations below. 1068 minus 204 is 864 minus 204 660, and minus 204, 456. Now, if you notice up here, you do get 1680, and I believe SAT scores only go as high as 1600. So this will happen sometimes where you're not able to actually get some of these percents, but we're still going to answer these questions based on what we have here. Okay, so the next thing we have to do, because it said clearly label, I need to label my 68%. Oops. Go to my next tick marks, 95%. I'm going to erase that thing. That thing's ugly looking. And then my last one's 99.7. Now there's going to be times that you're going to see things like this where 1680 actually isn't a number that exists for an SAT, but we're still going to go with it based on what we have. Okay, so this first question says, what percent is between 660 and 1068? So I'm going to highlight so that we can kind of see. And you're not going to want to highlight your paper because then you're not going to be able to unhighlight it, but you could watch what happens here. So 660 to 1068 is all this right in here. That's what I need to find. Okay. Well, there's some things that you should know. You should know that half of the data, right, lies to the left and half lies to the right. So there's a couple ways you could do this. If we think about just this section right here, this section right here, from one standard deviation above and one standard deviation below, is a total of 68%. So that means this little part here is 34%, and this little part here is 34%. Now, if we think about this section right here, 2 standard deviations away, we know that 2 standard deviations away is 95%. But I already have this 68% here. So I'm going to do 95 minus 68. And that gives me 27. But that's for both of these. So then I have to divide by 2. So that tells me this is 13.5%. And this one's 13.5%. So now you can see my yellow. My yellow is these two numbers combined. And so it's 47.5%. You don't have to show your math right here, but I'm just showing it because some people are going to have questions on how I got that. Okay, so now I'm going to keep those lines there, but I'm going to erase my yellow highlight. And let's do another highlight. This time above 1476. Okay, so that's everything over here. Okay, well, I don't have numbers in here. There's a couple ways you could do this. You could find out what's left over, right? So I know that 34, I know that these two here make 47.5. Well, isn't the distance from here to the end have to equal 50? Because it's half of the data. So I could do 50 minus 47.5. And that tells me it's 2.5%. That's one way to look at it. The other way to look at it is we could do the same idea as what we were just doing here. I know that that whole thing has to be 99.7. So I could do 99.7 minus 2, not minus 2, but minus 95. And that's 2.7. And I could divide that by 2, and that gives me 1.35. So that means this one's 1.35. Now, one thing you should notice, though, you remember it only went to 99.7, and it's supposed to go to 100%. So that is 100 minus 99.7 is a 0.3. But that's for both sides. So this number on the outside, let's find another color, do pink, is actually, oops, it didn't change my color. It's not changing it. Is 0.15. Now when you add up all of the numbers, get a different color. not working. What's going on here? Now what you could do is you could see that all of these numbers are supposed to add up. All those percents should add up to 50, and they do. 34 plus 13.5 plus 1.35 plus 0.15 equals 50. Now, these percents never change, so if you get in the habit of writing these little ones down or you recognize them, then you won't have to figure them out again. They're not required to be written down. The 68, 95, 99.7 is. Okay, let's look at the last one. We have all our numbers kind of there. It says what percent is below 864? So we've already done the hard work. 864 is right here. And so you're going to add those numbers up. So 0.15 plus 1.35 plus 13.5. And that's 15%. Okay? So when it says clearly label, you have to include the 68, 95, 99.7. But then we could also use these numbers to find out what percent of the time people are in between scores.